Okay, welcome to Unit 8, which is going to cover a couple different chapters, some of Chapter 8, some of Chapter 9, and some of Chapter 10. We begin in Section 8.1, where we're going to be constructing confidence intervals and interpreting them and interpreting the confidence level. We'll talk about sample size, how that affects the length of the interval, and then we'll get into like non-response, undercoverage, and response bias a little bit. So, first, some vocabulary: point estimator, point estimate. Basically, this is the estimate for the population parameter. So that's the point estimator. The point estimate is the value of that statistic from a sample. So 99% of the time, we're going to be focusing on the point estimate. Is it a sample mean? Is it a sample proportion? That's what we'll be focusing on almost every single time. Okay, so let's take a look. All right. So the idea of a confidence interval is just you're trying to come up with an interval like, hey, we're 95% confident that the true proportion of people who have blue eyes is between 10 and 20%. Well, how do we do that? We generate a sample and we want to take a random sample. So this is based on an activity. All right. So what we do is taking the blue eyes example that I just came up with, my point estimate would be 15%. So say 30 out of 200 people that we sampled had blue eyes. 30 divided by 200 is 0.15. That's my point estimate. Well, I'm not going to be certain that that is the true value. I have to have some like wiggle room, some margin of error, we call it. So I'm going to add and subtract the margin of error. It might be 5%. So 15 minus the 5 is 10. 15 plus the 5 is 20. So that's where I'm saying like, hey, I'm 95% confident the true proportion of people with blue eyes is between 10 and 20%. So, and then if the real parameter is somewhere in there, I wouldn't be shocked because I'm 95% confident that it falls within that interval from 10 to 20. Okay. All right, so this is kind of going through the interpretation. I just mentioned that. Interpreting a confidence interval, what is the point estimate? All right, so let's take a look at this one. If I'm interpreting this confidence interval, we are 95% confident that the true proportion of people who favor candidate A is between 0.48 and 0.54. The point estimate is the average of the min and the max of the interval. So if I just average 48 and 54, I'd get 51%. Majority means more than half. And you'll notice in the confidence interval, it dips below the 50%. If the entire confidence interval was above 50%, like say 51 to 55, then yes, we could say we're fairly certain that a majority supports candidate A. All right, that's just going through. Okay, interpreting the confidence level. So this is a really nice applet that exists. We'll use it in class, but confidence level is if we do repeated sampling, what percent of those confidence intervals that we create, as you can see here, will capture the parameter. The parameter here is this line. So if we have 95% confidence, about 95% of those samples create intervals that capture the parameter. That's what that means. So it's if we take many, many random samples of the same size, about 95% of those will capture the true proportion or true mean. So that's what's going on there when you're interpreting the confidence level. All right, let's do the check your understanding. As always, you work through it first. So pause the video here and then I'll go through it. All right, interpreting the confidence interval. This is talking about the population standard deviation. So we're 95% confident that the interval from 2.84 to 7.55 grams captures the true population standard deviation of fat in brand X hot dogs. Interpreting the confidence level, if we take many, many random samples of size 10, about 95% of them will create confidence intervals, or I'm sorry, 95% of the created confidence intervals will capture the true population standard deviation of fat content in brand X hot dogs. And then 3, I love this question. They like to ask this, that they being the College Board. This is false. Either the true parameter is in that interval or it's not. There's no chance. It's in there or it's not. It's either 100 or 0. So you could see for these two, I may have said it slightly differently than you're going to see in the answer key, but the idea is the same. Hold on, I want you to be able to see this answer. I'm not sure why it's not showing up. False. Yeah. Once the interval is calculated, it either contains the true standard deviation or it doesn't. Okay, moving on. So there's 3 parts that make up the confidence interval. We talked about the point estimate, that comes from the sample. And then we have the critical value, which we're going to need to get from the calculator, and then the standard deviation of the statistic. Okay. And these 2 parts that I just mentioned, the critical value and the standard deviation of the statistic, those are referred to as the margin of error. So there's a couple ways that we can increase or decrease the margin of error. One way is if you decrease your confidence level, as you can see here, going from 95 to 80%, that narrows the width of the confidence interval. The reason is I could say, hey, I'm 100% confident tomorrow we're going to get between 0 and 400 inches of snow, but that's not really meaningful. But I might only be 50% confident that tomorrow we're going to get between 1 and 3 inches of snow. So less confidence, we have less, a narrower confidence interval. We know what sample size does. As you increase sample size, it decreases variability. So as you increase the sample size, you're going to have a narrower confidence interval as well. All right, using confidence intervals wisely. Let's take a look here. Oh, that was a massive section. Let me go back. Okay, so a couple things. Your sample has to come from a simple random sample or stratified or cluster random sample. If you have any non-response bias, voluntary response bias, any convenience sample, the confidence interval is just garbage. It's not going to be meaningful. The margin of error, what that does is it covers the sampling variability from one sample to the next. So that's going to give you, like I said before, that wiggle room. So, and they put in here, under coverage non-response can lead to additional errors that may be larger than this chance variation. And that's why we're always using a random sample and trying to make sure that we have something specific that represents our population. All right, so summary. Point estimate is your value from your sample that you're trying to estimate. If I want to estimate the population mean, the point estimate would be the sample mean. If I want to estimate the population proportion, the point estimate would be the sample proportion. I have 3 parts that make up my confidence interval: the statistic, which is the point estimate, a critical value times the standard deviation, and these two, the product of those two is called the margin of error. We interpreted confidence intervals and confidence levels. Then we talked about 2 ways to decrease the margin of error. You can decrease the confidence or you can increase the sample size. So that's section 8.1 for you.